Suarez, Computer Engineering major.
My name is Rolando Mondeja, Computer Engineering major.
I'm Hassan Martin, Computer Engineering major.
Carlos Diaz, Electrical Engineering major.
Juan Baquedano, Electrical Engineering major.
And our project is to portal hands-free camera control system. The purpose of our project is to use the perspective of the viewer every time the viewer changes the position of his head to control a remote camera, so that the remote camera's position is in agreement with the perspective of the viewer, giving the viewer an illusion of a three-dimensional image on a two-dimensional display. Our project also will give the viewer the ability to use different devices such as an Android device to control the remote camera. This would use the sensors on the Android device as inputs for moving the two-axis remote camera.
Now let's take a close look to the communication protocol that we're using for the remote system. We're basically using TCP/IP communication on port 1000, and each of the packets contain 9 bytes, 4 for the horizontal position of the servo motor and 4 for the vertical position of the servo motor on the vertical axis. And then we have a final byte, which is value 10 on ASCII value. It's the null character. Each of these bytes represent an ASCII digit. It's a digit from 0 to 9, and the possible values are an ASCII value from 48 to 57. That will allow us to map numbers from 0 to 9,999, but for driving the servo motors, we're only allowed to use numbers from 0 to 8,000. So this protocol is more than enough to drive the motors and give the Arduino system the information needed to move the servo motors, both the horizontal and the vertical axis. And this is an example of one package. For the horizontal coordinate, we have 52, 48, 48, and 48, and that is basically 4,000. And then on the vertical side, we have 49, 48, 48, and 48, and that's 1,000. That will, whenever this package is received, it will move the servo motor on the horizontal axis to position 4,000, and then the vertical servo motor to 1,000. If we take a look to the servo and the way we manage to get that information on the servo controller and the Wi-Fi controller, we're basically, first of all, we should take a look to the code that takes care of the communication, which is the stack code. And here we are assigning the first 4 bytes of each package to this variable. It's an array of characters, and it's called horizontal position. And those are basically the first 4 bytes of the package. And then the next 4 will be saved on this array vertical position. And by declaring these arrays external, we are allowing to communicate the Wi-Fi shield with the Arduino, and the Arduino, it's basically getting those coordinates, those 2 coordinates captured in each package and processed by the software stack, and we're basically allowing the Arduino to get those coordinates whenever a package is received. There is always on the Arduino code some initialization code, and that is done in this setup function. Initially, we set up the Wi-Fi communication and the serial communication. We're using serial communication to drive the motors because we're using a servo controller that takes the commands from the serial port. So that it's used for that. And then we have initialization of the last position of the arrays for the horizontal and vertical position. We are activating the 2 motors that we're going to be using. This command basically activates all of them, but we're only using 2. And then, but we're using this function to send and drive the motors to a specified position which is the second argument. And then the third argument of this function is the speed to which we move from the position on which the servo motor is at the moment to the target position. And then here we specify which motor is the one that we want to move at that moment. We have two motors, so we have motor 1 and motor 2. This section of the code, we're basically setting up the initial position for the two servo motors. Both of them is 4,000. And then we start with the loop. This is what is going to be happening all the time. We're going to be taking care of the Wi-Fi communication, and whenever a package is received and is different to the previous package, we process the package. We get the true coordinates facilitated from the software stack, and we drive each of the motors independently to the target position, the position assigned from the package received. This communication happens in real time, so whenever a package is received, the motors are moved right away to the position contained in the package. Here we have an explicit code for each of the functions that we're using. First of all, we have the on-off motor, which allows us to activate or deactivate any motors at any moment. Here we have the function that allows us to move each servo motor specify.
Here we see video of the face tracking component driving the remote camera. The face tracking component is connected to a host computer which performs the computer vision algorithm using the OpenCV library, and it attempts to keep the viewer's face in the center of the screen, and it does this by repositioning the motors on the brackets, and this is done using a USB servo controller. The position of the motors is then converted into pulse widths that can be used to drive the motors on the external camera. The reason why this is done at the host, at the client side, instead of at the server, is that the server is implemented using an Arduino microcontroller, which has very little processing power. So to free the Arduino from the burden of having to do these kind of conversions, while at the same time having to run a socket server, which is itself computation intensive for the Arduino controller, we perform that computation on the client side.
One of the main objectives of this project is to make the users feel more comfortable and engaged to the project and the applications, and that's why we took on an Android application which will be driving the remote camera, but this time it's not based on the face tracking algorithm that was explained before. This application uses the relative position of the phone with respect to initial position of the phone, and then from that point further movements of the phone and relative angles will be translated in commands to the remote camera. The angles and the relative position of the phone will be driving the camera in such a way that will let the user feel like the movements are natural. A movement of the camera to the left will be translated in a movement of the camera to the left, and then the video feed will always be shown on the screen. The final result, it's an app that let the user drive a remote camera with natural movements without having to interact much with the screen. You can drive the camera as you move the phone, like if you were moving a camera that is in front of you.
but the difference is that the camera it's probably thousands of miles away.